welcome. This is the first of our sessions for Production Ready Spring, and I lead the marketing team for the Townsend division of Broadcom. Just very happy to have you, and very humbled to be leading a fantastic panel today. Really picking up from Rod's keynote, going deeper and deeper into AI, and really key into what I feel is the sense of wonder and excitement at the same time, high anxiety all together. I saw a fantastic stat yesterday from an enterprise survey from IDC, and they were talking about the anxiety levels among teams within the enterprise. And in the developer community, relatively low. Security, sky high. All your IT folks, they're scared, right? They're all under pressure. So lots of folks trying to come together to figure out how to make this stuff real, how to take all the really cool things that we know AI can do, but how do we make it, again, predictable, more deterministic?
Are you saying this is as a result of the impact of AI? I'm sorry. Are you saying this is as a result of the impact of AI or the perceived impact of AI?
Or the promise, let's say.
Oh.
Yeah.
Okay.
So thanks for that. So with that, I'd like to quickly introduce the panel. I've got Adib Saikali. He is an enterprise architect and distinguished engineer with the Townsend division of Broadcom. We've got Josh Long. He is a Spring developer advocate and probably needs little introduction in this room. And of course, Rod Johnson, a creator of Spring and founder of Maintainable. So thank you all for joining. So to get us kicked off, why not? So to get us kicked off in one sentence, what is the most dangerous assumption that dev teams are making about AI right now? And maybe I'll start with Rod.
I think the most dangerous assumption is that it shouldn't be driven from Java. I think I'm seeing a lot of organizations where they're assuming that it should be driven by data science, and where Java developers are not actually as much part of the conversation. So I don't think I really answered the question terribly well, but what I would say is that a major cause of things going wrong is the Java people not having enough to say in the story, and I would encourage everyone to learn about the technology and contribute more because you are critical to your organization's success with AI.
That's great. Josh, anything to add to that?
I couldn't have said it better. We have a unique opportunity as JVM and Java developers. Obviously, when we say Java, I assume we interchangeably mean Kotlin and
JVM.
Yeah, the JVM. Yeah, we have a unique. Nobody else has this opportunity, and we're seeing it, manifest itself more and more. Because remember, most of the interesting bits related to AI engineering have nothing. There's nothing endemic to them that require Python. There's nothing at all, right? Quite the contrary. It's an integration game, and there's nobody better suited for that than we are.
I think the most dangerous assumption is that the people may have tried out a little bit with using some of the coding assistants and getting some stupid results out of those and forming an opinion. This stuff is moving so fast. Whatever opinion you formed last week, just check it again next Monday, okay? Because it is really worth it to go through and do things perhaps the slow way with some AI agents compared to, I know you could probably do it faster without the AI agent, but if you don't do it with the AI agent, you're going to miss out on learning how to really drive these things.
All right, it makes sense. So with all the amazing things and all the fantastic innovations that we see just changing from week to week, what is the industry getting wrong, right? Why isn't this easier for us to use in the enterprise today?
AI?
I think what the industry is getting wrong, personally, is that people are putting either too much hype into expectation on what AI can do for you, or they're putting it, they're saying it doesn't, maybe it doesn't work. So the too much hype would look something like expecting the AI to do things that humans can't do, or expecting the AI to be more perfect than humans. Well, guess what? These AI models are probabilistic. They're trained on a lot of data that comes from humanity's output on the internet and other places. So they have the same kind of blind spots we have. So what you want to think about it is, think about it as a system rather than the AI as the model. It's the things around the model that actually make the model useful in the enterprise. And you have to find the right way to do, to think about it. I'll give you maybe a bit of a strange example. I was talking to a friend who's recently back in the dating market, and he was like complaining about the app. So he wrote a bot, of course, with Gen AI, swipe left, swipe right, whatever it is, to try to get dates. And he's like, hey, let me turn that into an application. I'm like, no, you have to think about agentic dating. In that scenario, what you really want is you want to get your profile written by an AI agent, and then you want to put that on the internet, and then you want your agent to talk to the other people's agents, and then you can I don't know, meet up for coffee and do a group date. My point is, like the enterprise, you have to think a little bit outside the box to say, what does this mean for us in our business? And how do we use agents, and how do we re-engineer some processes around AI?
I think the biggest mistake people make is thinking about it as a greenfield problem. So, as I mentioned in the keynote, take memory. Very important topic. The vast majority, in fact, I don't think I've actually read a single blog about memory. It's not even the vast majority, it's the totality of blogs not written by me about memory seem to neglect the idea that you might have to link into existing data.
Josh, in your travels, what are you seeing Spring developers doing today, right? What do you see that's working?
What's working? With AI, yeah?
Yeah.
I think people are finally starting to glom onto the idea of they don't need to be using the frontier models, the hosted multi-tenant frontier models. A lot of them are using on-prem models, and with great results. And that's, I think, assuaging some of the concerns that some of them are having about data tenancy and privacy and sovereignty and things like that. And what things like sophisticated agentic patterns as enabled through Spring AI, and of course with Enable and so on. What that enables is the rigorousness to take these models that are on-prem, because even the best models, even the frontier models, are not going to get it right all the time. But if you build process around that, if you build workflow, if you build that kind of stuff, and so they're realizing that you can actually have your bank appropriate AI, right? You can have enterprise grade AI. It's not just a whiz bang science project.
Great. So let me turn the corner a little bit. In the keynote, Rob, we talked a lot about determinism, and I think engineers, developers, we love determinism. We love to know how things are going to work, and feel confident, right, and be able to trust what's happening. So if we think about how to make this successful, what parts should be deterministic? What parts should we let the agents go do their thing? When is that wonder and surprise a good thing? And we're really getting the leverage, right, that we sort of expect, versus like really pinning it down, right? You talked a good bit about this in the keynote, but where do we draw that line today?
I think the first thing that you need to do is consider the requirements for the task in hand. So even within the one organization, different tasks might have different requirements. Secondly, you decompose the task into as many steps as you can, and look even at those steps and see how much determinism can be in those steps. If your particular step can be implemented in code, that's always going to be faster, cheaper, and more testable. But you also might find that certain steps you want to grant the model more autonomy. An interesting example of that is RAG, where agentic RAG is pretty great. And that's actually giving the model more autonomy, but in the bounded context of a particular step.
Yes. And Josh, how much of this is a technology thing versus a cultural thing, right? Do you think differently when you think about coding with AI or trying to code an agentic app?
Oh, two different questions. Coding with AI, yeah, that's been kind of interesting. Actually, I would love to I'd love to hear all of your perspective on that. Coding with AI for me has taken a lot longer than building with AI. I feel very comfortable building integrations and solutions on top of AI, and I expect that since it comes packaged in a nice familiar Spring idiom, people will feel comfortable speaking that language when they need to. But coding with AI, has been it's been interesting. Yeah, that's different. Yeah. So the question then was,
how much is a cultural shift, right, versus just the technology?
okay, yeah. So for building solutions with AI, I feel like it's just another thing with which Spring integrates. It's possibly one of the most important things, but it is another thing. It just feels like it's right. It's start.spring.io and off you go, right? But coding with AI is definitely a cultural shift. It's like when people learn to do test-driven development. It's a inversion of the normal paradigm. I now find myself as quickly as possible finding a way to push myself to be product manager, right? A product manager who codes. We used to say that the CTO who codes is the best CTO, right? Who can code at least, right? Same thing. I find myself, you're very, very useful if you can code, but you still need to learn to delegate.
Yeah, I mean, I'm using coding agents very heavily, and I think the role of design is still, we still need to play the role of designer. I don't think even the current generation coding models are very good at design at all. But as Josh said, you become like a product manager and an architect where you're reviewing things. And one of the beautiful things about it is you don't have to be nice. Like, probably all of us who've been team leads or architects have had the experience where you have to tell somebody that they just wasted 2 weeks. And, you have to waste a lot of time doing it because you have to be nice. You have to try to find something good in what they did because you're telling them they're going to have to rework what they spent a great deal of time on. Well, firstly, it doesn't take the coding agent 2 weeks. And secondly, I don't know why, but it makes me feel better. I'll sometimes say in all caps, no, do not do X. And it doesn't hurt its feelings.
I saw that. No, I would be careful though. I've learned you got to be. Look, I saw this documentary called The Terminator, and I understand they will not abide vulgarities and impoliteness.
I'm sure they're logging it for the future.
Exactly.
Yeah, I'm probably in deep trouble.
When the machines rise, we'll all pay. Yeah.
So, Adib, we're talking about trying to build trust and predictability out of these systems. Like, where else do the guardrails belong, right? Beyond just the planning side.
I think one of the most important things is that you want the verification to be deterministic. So if you are building an agent, for example, in any type of industry, the key thing is that the agent is very creative and it is able to interpret your human intent. Like when you're talking to these agents, you can make typos, make mistakes, and you hope that you told it enough for it to do something. But how do you check its output? So one of the reasons why coding agents are very effective is that we have 2 verification systems that are deterministic. Number one, you have the compiler. If the code compiles, good sign. If the code doesn't compile, then the coding agent sees the error message and tries to fix it the same way you would as a human.
So you're saying having a compiler is good?
Having a compiler is great. Having types is even better.
Yeah.
It would be like less confusing for the AI agent and for the human. And then the second thing is deterministic thing you have are your tests, right? So what happens in these systems is you really need to invest a lot more in making really good tests, in making tests that are more end-to-end. So a lot of the time we can get away with just like, oh, it's just a unit test, but okay, one component works. But how does the agent know that it all works? Now you as a human would probably at some point go and do an end-to-end test. So how do you make tests more readily available to the agent? So those are the main things: deterministic verification and non-deterministic probabilistic interpretation of human intent. That's the ideal combo.
Awesome. that takes us kind of right into the next area of just testing in general. It's probably true that many developers don't already spend enough time, in testing, versus, writing code. Does the problem get worse, right? How do we, think differently about testing in this new world? Rod?
I think all the forms of testing that we've traditionally done are important. So unit testing is also really important. So often you can encounter problems in prompt construction. Obviously you can't test how the LLM will parse the prompt in a unit test, but you absolutely can test that you've got the customer data or whatever that needs to be in there, and that can help you with a whole host of problems. You can also do things like unit test the size of prompts, make sure you're not accidentally bringing in enormous amounts of content to prompts. I think integration testing is also really important, and one thing that we've seen is in our internal apps, we're building a lot of tests that are in Spring terms integration tests as far as Spring's concerned, but with the critical difference that they're using a real LLM. So they're integration tests in that they're working, say, with test containers, so that it's not a real database. It's the real database technology, but it's not a production database. But we're using real LLMs, and that seems to work very well. They tend to be quite coarse-grained compared to traditional integration tests I've seen. And typically at the end we make a whole bunch of assertions about things in the database to verify, say, that a knowledge graph was built up or whatever. But that seems to me to be a form of testing that I kind of haven't seen that much before, where it's partly using a real resource. And of course, it's partly costing real money.
One of the things that kind of relates to that is I found myself writing a lot more integration tests these days when I'm doing agentic coding, when I'm coding with a model, because I want it to have the ability to verify the whole end to end, and I want to be able to say, here's the task, and I can go make coffee. Like if an integration test takes a long time to run before AI came about, I'm the one on the hook waiting for it to finish. But I don't care now. The model, just let it churn. It's a better test because it integrates,
Yeah, I think that's really, really important. I find that, I think Adib spoke eloquently about the fitness functions that are so important for coding agents. If you can actually get really strong tests that are end-to-end and work with real LLMs, you can give your coding agent more autonomy because it can iterate until those tests pass.
So one of the things around testing that I haven't heard a lot of people talking about is you have to go, especially if you build your own agent that you deploy to your own employees or to your customers, you have to go a little bit more like call centers. When you call a call center, they go, this call is being recorded for quality control, right? Like, why do they say that? Because you can ask two humans the same questions, you get two different answers. You can't do like an if statement comparison, but they mean the same thing, right? So the key to testing is to get to a model where you can do continuous testing in production, because you're capturing the responses that are being generated from your own agents, and you are then evaluating how well they fit certain criteria. So probably you're not going to evaluate them all with humans, obviously, but you could have multiple layers. Perhaps you use some models to check up on certain things, minimum quality control. You might be able to sample a bunch of those, maybe like 10 per hour or something that some human might look at to see whether it was good or not. So from day zero, integrating some sort of feedback from the humans, like the simple thumbs up, thumbs down, did the agent produce what I expected or didn't expect, is really important. This is why I love, like, in general, Spring and the Spring ecosystem, is that we have all of that baked in, right? So with Spring AI, for example, you get all of the metrics on all of the technical stuff like latency, how many tokens something is consuming. You also can capture all of the actual prompts and responses that came back from the model. You can take that, you can throw it into a database, you can then build some automated evaluations on top of that. So start thinking about testing that is beyond what you do before you release the software to something that you do before you release the software and something that you do while your agents are in production.
All right. So we'll turn the corner again, and there was some recent news from Cloud Code, right, talking about COBOL, right, and how many COBOL developers, right, are we going to need? So, and we watched some stocks drop from that. But if we project the next 5, 10 years, how much is language going to matter? Do you have any opinions at all?
This is a fascinating question, and I don't know if I have opinions. I have thoughts. Because you could make an argument that language matters a lot less. And therefore that would enable coding agents to choose languages for particular applications where you literally use what is best for the application versus what your team already knows. I think, unfortunately, while that theoretically is attractive, there are downsides to it. We already saw with microservices that having loads of little applications is not necessarily that good. But secondly, readability is absolutely critical. I would say most likely the effect on languages is good for readable languages. Like, I would actually say it's probably a positive for Java because Java is a readable language. I mean, Java is in some ways an annoyingly verbose language. I must admit, every time I wrote notice I say past tense, wrote a Java constructor, it really annoyed me that I'm duplicating all the fields. I mean, that's just, it's not how a modern language should be. But guess what? I don't write Java constructors anymore. I can't remember the last time I wrote a constructor. So the coding agent writes the constructor, and I mainly consume that code through diffs. And Java's actually really good for that because Java's very readable. So, when I'm presented primarily with a scenario where I'm reading code rather than typing in a verbose language, Java actually is really good. I would say that Python, the same is true. Python is actually quite verbose language. I don't know why. Apparently nobody ever complains about language verbosity except in Java. But Python is a verbose language, but it's also readable. So I would say it's good for Python. I'm not sure it's so good for languages that are super concise and not readable.
You just mentioned the readability, and I couldn't agree more. There's also. Do any of us think that you just said it? The models don't do design work yet. They're just not there yet. There's a certain level after which human beings are going to be involved in the production process with code, and that requires expertise. And so, to the extent that you have an expertise in a particular language, I think these models will be very useful. Let me finish one more thought here. Or no, do you want to interject?
No.
Okay. I was going to say. I just wanted to say I found that the models are very good at raising my level of expertise in things in which I'm not an expert, but the things for which I'm already an expert, vanishingly few, but they exist. It doesn't actually help, and so having the ability to, as an expert in, for example, Java, to be able to scrutinize that code is useful. I wouldn't know that I was being what's the right word? Bamboozled, hoodwinked. If I didn't understand the code.
Yeah, I think that's a really good point. Certainly, I find in my daily work I use code agents very extensively. But, obviously I know Java very well, I know Kotlin very well, I know Spring and in Babel very well. And that knowledge all gets used a lot. Like, actually, somewhat to my surprise, given it's pretty good at Kotlin, I actually showed Claude something it didn't know about Kotlin companion objects. And I guess it wasn't hard to see why, in that I've literally never seen anyone do it. I know you can do it, that companion objects can participate in inheritance hierarchy, but I've never seen that code written, and clearly Claude hasn't either. But I think, as Josh said, absolutely understanding what you're working with is the only way to make using coding agents safe, because design is not terribly good, And that, again, is an argument for converging on the stacks that you already have and already know. Because, sure, Claude would be perfectly happy to write something in Rust for me. I don't really know Rust. I couldn't give it the guidance. I'm sure the design would actually end up being pretty bad. With respect to mitigating the design shortcomings, by the way, the best thing is give it examples and examples from your code base. So I will very frequently direct it to look at the closest thing and also communicate at a high level. So, for example, I'll frequently say, X shouldn't be a class, pull out an interface and use the strategy pattern. And it understands that kind of thing. This, I should put in a plug for Spring and my personal coding style, which is reflected in Spring. Spring has obviously attracted a great deal of mirth over the years from the fact that it's relentlessly consistent in naming, etc. This is the consistency inside Spring is really helpful to agents. They grok Spring at a very deep level because of the consistency.
By the way, the fact that you can speak design patterns just shows that it was worth learning that book.
Oh, totally.
Oh, sorry.
I was just going to add two things to this. One is if you look at how models learn about something, there's two places they come from. Number one is you can have something that comes from the model weights, which is something the model learned during training. So for example, the knowledge that Claude or OpenAI has or any of the coding models about Java comes from all of the Java programs they've read in the open source community and other places that are reflected in the model weights. So the advantage that you have when you look at these is the older your framework is, the older your programming language is, the more examples there are in the training data set that was used to train the model. So something like Spring that's 20 years old has quite a lot of examples from really bad ways to do things that are deprecated now to newer ways of doing things. So your foundation model are already good at Java and Spring. The second thing comes from is in-context learning. So that basically means information that you put into the prompt. For example, you can create an agents.md file or a claude.md file, and then you say, hey, when you generate this controller for Spring, please follow this style. Don't do it this other way. And so given that that is the case, I would argue that the ecosystems that are going to prosper in the age of AI are going to be the ecosystems that have an unfair advantage in that they're in the model training weights. And the second one is that it's easy for people and for agents to create these in-context learning examples. Like, see the pattern over there? That's what I want you to copy. And that's going back to Rod and Josh's point, the consistency of Spring, the repeatability of it becomes a huge advantage. One of the nice things about AI models and agents is they have no opinions. I love that, right? They just don't complain. So they're actually benefit from all of the stuff. You can use like a scale.md file or something to say, this is the pattern I want you to follow. They see the pattern in your code and they follow it over and over again.
I have a question, not an answer. You just mentioned something which we all, I'm sure, have thought about, but at some point there's going to be decay, right? Like at some point these models are going to be trained in code that they themselves wrote. And has anybody thought about having like a little, like is skills.md a sign that these models should not consume that GitHub repository in this next round of training because it is built on code that was based on, like, how do we know? They got to leave some sort of marker to say, hey, don't read this. You're just, you know what I'm saying? You can't just drink your own urine over and over. You know what I'm saying? At some point you get a problem.
Interesting question. I think it comes down to how heavily you use coding agents. And I would say that most of the code that I produce now using a coding agent is as good as I would write myself, because the design reflects my input, like totally. It's my design, even though I wrote very few of the characters. Sometimes the most efficient way to communicate that design is actually to stub something out. So for example, I might stub out an interface and a few data types because it's just quicker than explaining. Sometimes it's refer it in the prompt to the closest thing that exists to this. But I actually think that if you're disciplined in your use, you can produce high quality code.
To answer Josh's question, I think that all of us here learned what an if statement was once, right? Next time you went to a new programming language, you didn't have to learn what that is. So if you look at it in terms of you're training these models and you're feeding them code, at some point, like giving them more code on something may not teach them anything new about that language. So where you'll find that you do need to give them example if there's new features. Say, for example, you're asking the agent to build something in Java. You might want to prefer to do things with immutable objects always. Like you might be like, please use records. Don't use mutable classes. When new features ship, like say virtual threads, teaching it to prefer that. So this is where I'm not concerned personally with running, that the world will run out of data for training the coding agents, because it is already, there's so much of it that they're already really good at it. Architecture, on the other hand, that's a different story.
I'm worried that it'll start learning. I'm worried that it'll start reinforcing the weight of bad vibe-coded design by consuming more and more of it.
An interesting point.
Yeah, I mean, that's the doing it the wrong way, because that could happen. But this is why I think it's really the quality is going to have to come from some sort of deterministic verification. So this is where I see, for example, you've got things in the Spring ecosystem like modulith. Perhaps you want to apply some modulith checks. Perhaps you want to apply some Arch unit. Perhaps you want to apply some of these kind of tools that in the past you wouldn't want them. Why? Because you're a human. You don't want the robots telling you your code is not so good. And then you're like, what do I do with these warnings from SonarQube? Should I go fix them? I don't know. That doesn't sound like fun. But the coding agents, on the other hand, they can act on that machine feedback and they can improve things. So
I wish you're right. 100%. But also, I like the idea that, do you sit there and look at responses from the output of the tools and go, that doesn't look like fun, and then move on to other things? Or because that's a great way to live life, I think. I don't know.
Yeah, I mean, so this takes me into maybe the last question, and please, those of you in the audience, think of some questions. We get through this. I do want to open it up to the floor here, and just building on the last thing you were saying. I had read an article where, again, the expectation is that we want AI to build better code, and there's in more and more quality code in the way that with the structures, right, that we would expect, right, as good software engineers, myself excluded. And there's the other argument that says, who cares, right? Let it write as messy and as overly verbose and repetitive, nasty code as possible. And if it works, and all of it in the automated verification testing and everything else is happening continues to work, does it matter? When does that, how does that play out over time, right?
I think we just said that, right? Readability matters.
Yeah.
Somebody's going to have to read it.
Yeah, I think readability matters. And I think design matters because, a lot of the things that good design exists to do, for example, is reduce code. So you will end up with less resource consumption. You will end up with better performance if you have a good design versus a bad design. My experience, and I've deliberately run experiments where I've kind of vibe coded things, my experience is rather quickly, if you don't give it any design input, you get to the point where it cannot deliver new features without creating bugs. Because, if you don't have good design, sure, all your tests might work now, but you're always going to have to add new features, or you're always going to discover new bugs, and your ability to rectify those on a terrible code base is still very compromised.
I'm going to maybe say something the opposite of what you all expect. I think the code quality coming out of coding agents is far better than what most developers write. Okay? Now, the reason why I make that claim is that call it the 500 lines or below level. Okay, 500 lines of code is all you really need from a coding agent to do something. It's consistent, it's high quality, you can tell it exactly the style that you want, and you will get that. That doesn't mean you're going to have a system that is going to be coherent. Because if you're building a house or anything like that, you have like individual craftspeople that will come, they'll cut the wood, they'll do all of the stuff. And if they do bad cuts on the wood, your wall might be crooked or something like that. But that's why they cut with machines, right? Like if I'm trying to cut a really straight piece of wood, a board, a long one, if you do that by hand, it doesn't work as well if you use one of those like cool saws that just gives you the perfect smooth edge. So I think of the coding agents as being tools that give you a consistently repeatable, high quality output, but then the putting together of all of the little individual pieces of high quality output is still the responsibility of a human to coordinate. So I design the house. I decide where the windows will go. I decide where the walls are going to be. And if what's cool about the agents is if I go like, I think this room should not have this wall over here. Please move it like 10 feet out. That's something you can ask a coding agent. In the real world, you can't do that, right? With one-off decisions. So make one more point. One thing that's going to change a lot about software development is right now I find myself still in way too many conversations with colleagues. We're debating how to solve a problem. And because it takes effort to solve it. We can only try one solution. And we're really at the cusp of, you never have to do that again. Like, if you think of 3 ways to solve a problem, don't debate it for a week. Just ask the coding agents to try all 3 and pick one.
One thing that I agree with Adib, that I think that a good developer working with a coding agent can produce better code than the developer would, and better code than the coding agent would. Far better by vibe coding. I find it helpful to think about interactions with LLMs like search. So basically what you're doing with your prompt is you are searching in the LLM's memory space. Case in point, very early on, some of the first code I asked an LLM to generate was to parse a string that might contain JSON at any point. It's a surprisingly hard problem to do that in a robust way. So it wrote some code that worked, but was ridiculously slow. It was order n squared. So I said, that's really slow. Can you optimize it? So it moved a few deck chairs and probably made it twice as fast, but it was still order n squared. So then I said, that's really inefficient. Use a finite state machine. And it wrote me a beautiful finite state machine, which was way more efficient. But interestingly, it hadn't thought of that first, because it thought of how the average programmer would approach this, which was obviously terrible. But when you actually got it into thinking about, now I think about the state machine concept, it could write a beautiful state machine.
You got to know what it doesn't know.
Yeah.
Just that.
Yeah.
Yeah, and I don't know. I saw this tweet yesterday. I don't know if it's true or not, but apparently Donald Knuth was saying that Claude proved an open problem that he had in one of his books that he's been working on for weeks. Yeah. And he wrote a paper, and it's like Claude is the author. So that's why I'm like, don't. Personally, I'm not afraid of these tools. I see them the way I see construction tools. That my cousin is a contractor. I'm like, man, he can do so much stuff with these tools. Like, I bought some of them from Home Depot, and my stuff was so bad, right? Yeah. I'm like, they're just collecting dust in my garage forever. So just learn how to use these tools. It's going to be so amazing what you can do, what you can build with them.
Yeah, I mean, I think we have all said at some point the same thing, which is this is an opportunity for most of us to become product managers or to become higher level in the value chain. But it's a wonderful opportunity because your output will go better, will be higher, and you get home on time. It's better.
Yeah, and if you put it that way, it really is just a natural continuation of things that have been occurring in programming forever. I mean, we started off with machine language, then we had assembler, then we had languages like C, then we had Java, and then we had Spring, which, basically part of my motivation for creating Spring was seeing junior developers type over and over, code like try, catch, finally, try, catch blocks, except it was always incorrect, so it was just try, catch, finally. People were typing things that just could be moved inside a framework. So I would say that conceptually it's just the latest and probably most important single step in an inevitable trajectory away from the machine to higher level concepts.
I don't remember people in the '60s complaining about the compilers taking all the jobs. I think it's just a natural next step.
Well, then, of course, the interesting question is software is obviously going to be easier to write, but we probably need more software because of AI. So I don't know where that balances out. It's quite possible that our need for software will be so much greater that there will actually be greater need for programmers, even though each programmer will be way more productive. One thing, however, there will absolutely be zero demand for within probably a year is programmers who don't use AI. That's anybody. Occasionally you still see Luddites on Twitter and LinkedIn. Good luck in your next career.
Yeah, so it does take us into our last question. Just 2030, only 4 years from now. Not 2030 used to be that thing that was way out there. It's only 4 years away. How do you see yourself working? How does your job change?
So for me, 2030 is, I see myself kind of being able to use partnering with a whole bunch of coding agents to do a lot more sophisticated work that is impossible to do today. In particular, it's the ability to try out many more designs than would be feasible. I've worked with a lot of customers over the year, and we have so many things in our process. How many people here are developers? Raise your hand if you tried to clarify requirements, right? Because the requirements were wrong, and then we all complained that, oh, the PMs didn't give us the right requirements. We built something according to the specs. We showed it to the users. The user said it wasn't what they wanted. And so the amount of iteration that we're going to do, we're going to be able to do is so high that I expect myself to be generating a lot more solutions and testing those solutions with actual users and then picking the best one. End result being much high quality software than would have been possible before. And then lastly, I do not expect to be paid for what I know, because every coding agent knows more about programming than I will ever learn. Like, there's no chance I know more than Cloud Code about Java or any language. So if I can't get paid for what I know, I can't think of myself, I'm a Spring developer, I'm a Java developer. I have to think of myself, I'm a builder who creates things that solve problems for other people. And that's a big mental shift from thinking of myself as the thing that I can do.
I don't know if I'll be writing any code in 2030. I would say I'll probably type 0 lines of code. I think that everyone's job is going to change profoundly because agents will be involved in practically everything they do. And that will go beyond coding agents. So I think to some way OpenClaw is showing the future direction, whereby every device you have will be connected to your agents. And in fact, I suspect that there will be a lot of innovation in interfaces where a lot of the assumptions that we have around how we interact with computing are going to change when it's possible to bring that interaction to us in different form factors.
I think that's true. Tangent, because there's nothing else I can really add. I think in 2030, I'll exactly as you say. I do think the security space will become a lot more interesting. As right now, it's very important to have security around human beings in a big, scary world. But as we start to deploy on our behalf as our envoys, more and more of these agents out there doing things for us in our homes. Imagine a smart home connected by agents. Imagine your kitchen and your microwave all talking to each other via agents. I know I sound tinfoil hat guy, but nonetheless, I don't know that it's that far flung. You said multi-book, open cloud, whatever it's called these days. Yeah. As that shows, there is a interesting possibility and a real security risk, right? Today, which I think we could do well to fix.
Yeah. I think OpenClaw is certainly not the incarnation of the future, but I think it definitely points the way.
I just want to build on Josh's point about security, tell you an actual bit of a scary story from last week. I was mucking around with an experiment with getting the agents to kind of complete an OAuth device flow. So I told Goose with Claude Opus, like, I have localhost 8082. There's an API running here. It has a resource /protected. Can you figure out how to access it? So what it decided to do was to use lsoff to find the process ID for 8082. Then it decided to do PS to find the directory where this was launched from. Then it went into that directory and read the code and came back like, oh, I discovered there's a Spring application. It tries to access the protected resource, gets a 401, which is exactly what should happen. And then it decided to change the Spring security configuration. I'm like, hey, Claude, stop. I asked you to politely knock on the door. I didn't ask you to bring a tank and shoot the door off. So yeah, security. It's a big thing. It's like I'm a huge like security advocate. At the same time with this, like, don't fool yourself into all these problems. We will solve them. All the security problems will be solved. So don't use that as an excuse not to experiment and do stuff with AI today.
Awesome. With that, I do want to open it up to the floor. Let's see.
I'm contractually obligated to tell you we have trading cards that I want to give to all of you, whether you want them or not. So come take them. They're here.
Awesome. So what I'll do is bring this microphone around so we can make sure we get the questions on tape here.
I'm guessing the issue that I'm having in my organization and sort of like reflects here in the conference is that most of us are JVM developers. That's why we are here, and we are convinced about JVM's role in enterprise AI. But how do you convince the other folks who are not here and who are not in the JVM camp? Like, is it a marketing problem? Like, oh, Java is slow and verbose and the garbage collector is an issue?
Okay, so the question is, how do we convince everybody else who's not a Java developer? It's pretty simple. Here's how I talk to executives about it. I'm like, until you get your AI application into the hands of a customer or the hands of an employee, it is a cost. It doesn't return any money to you. And currently, what I see in a lot of places, you have centers of excellence that are doing AI, and those centers of excellence have a lot of people from a Python background. So the first couple of agents they build, first couple of solutions are built with Python. But those people don't necessarily know all the intricacies of the existing systems where all your data lives. And there's not enough of them to go and learn all of the years of subject matter expertise that the rest of the org has. So the argument is pretty basic. Do you want to take a day and turn all of your Java developers into AI developers? Or would you like to send them to a lot of trainings to learn Python, right? Or are you going to go hire a lot more Python people that don't know your business, right? So I would just make a pure pragmatic argument of it's doable and we don't have to retrain and we could be working on ROI returning projects right away.
Yeah.
And also, I think, make some of the points that I made in the keynote, that data science is not the same as Gen AI applications. And while Python's very strong for data science, it really is very weak in the enterprise. Also, this is one of the reasons that we emphasize in Babel the fact that we're innovating, we're not copying. So, for example, resources like some of my blogs actually directly compare code written in Java with code written in Python. Like one of the first ones that I did with Crew AI, believe it or not, there's significantly less Java code than in the Python code. Like by a factor of probably about 30%. There's actually a little bit less YAML and significantly less code. So, I think advance some of those proof points, which will quite surprise people.
The other thing is that it's also infinitely more energy efficient, more performant. I mean, we saw the MIT study last year that suggested that like 90% of AI projects fail for exactly what you just said, which they fail because they're not being aligned with existing workflows. Those workflows are built in Java. It's much easier to hang these new integrations off the end of those. The other thing is, you saw the TMD benchmark that came out for the MCP stuff a few weeks ago. Like Java's, what was it? Orders of magnitude, like many times faster than everything else except for Go, and it was faster than Go, but only by a little. But it was orders of magnitude faster than TypeScript and Python. It's way more energy efficient, does more transactions per second. Like, it's not just a better ROI scenario, it's also a technical superiority. It's better all around. You shouldn't have to make the case. It's just tell them to defend Python. That's much more interesting because they can't make that case. They can't.
I'm going to tell you about two actual structural advantages Java has for this. So number one is that as more and more code is generated by coding agents, how do you guardrail what the coding agent is actually outputting, right? A lot of systems, like especially very dynamic languages, monkey patching is possible in a lot of languages. That's kind of not what you want your coding agent to be doing. And so in the Java ecosystem, we have a lot of really interesting tools. For example, anybody here using ErrorProne?
Yeah. No.
Okay. So it's a Google project. It's an extension of the Java compiler. It lets you actually generate new compiler errors. So one of the things that I expect to happen in the Java ecosystem is to emerge with kind of like more verification tools that are deterministic, that check the quality of the code that's being generated by the coding agent. And if you give the coding agent feedback in the form of a compiler error, it's much more powerful feedback than by giving it via prompt. Please, agent, dear agent, be kind and generate this kind of code that looks like this.
Begging-driven development.
So that's one thing. The other thing that I'd noticed the coding agents do in the last 2 weeks is they're not going and reading the docs and the source code. When I ask them to troubleshoot, they're searching inside of jar files in my M2 folder. They're finding individual class files. They're using Java P to print out the bytecode. And from that, they're actually figuring stuff out. So the fact that Java is compiled, but it's also dynamic, is starting to dawn on me that maybe this is actually an advantage for the coding agents. And that could become an advantage too at runtime when you're trying to troubleshoot these systems, because you can get just a lot more information about the state of a JVM than you can typically of a Python process or a Node process. So I'm not worried about Java on the Gen AI world.
So on that bullish note, we were at the top of the hour. I want to get you on time into your next session. Thank you very much for joining us today, and thank you to my fantastic panel.
Thank you, everybody. Kevin, can you get a selfie with our